Okay, so let's go back over to our examples, and we have a few more examples to work on. So let's look at C, D, and E. Hopefully you're recognizing C and D as needing the quotient rule. So C, actually, you could use the quotient rule on it, but let me tell you a general rule. If you have just a number in the numerator of the quotient, you're going to want to write this as -3 times 4x plus 1 to the -2 and use the chain rule and not use the quotient rule. The quotient rule is a much more complex rule and has lots of places to make mistakes with the minus and the denominator. So I strongly suggest that if you have a number in the numerator, you rewrite. And it will work if you use the quotient rule, as long as you remember that the derivative of the -3 is 0, but that's a really common error. So we're going to see this as a chain rule problem, and we're going to see the g of x, the inner function, as the 4x plus 1, and the f of x, the outer function, as -3x to the -2. Then the derivative of that is going to be 6x to the -3. So our y prime is going to be 6. Put the g function in the f prime, 4x plus 1, to the -3 times the derivative of the g function, which is 4. So your final answer with no negative exponent in it is going to be 24 over 4x plus 1 quantity cubed. Okay, so that was C. Now let's look at D, and that one you need the quotient rule for. So let me just copy it again here, so as I go downward, you'll still be able to see it. Okay, so this is definitely a quotient rule problem. So we have u, the upper function, is x squared plus 5x. And v, the bottom function, is 3x plus 1 cubed. So you need to recognize that the v function needs a chain rule to find its derivative. So let's go here to another area to find v prime. So g, the inner function, is 3x plus 1. Then f, the outer function, is x cubed. The derivative of f is 3x squared. Then you take the g function and put it in the f prime. So then our v prime is going to be 3 times 3x plus 1 squared times the derivative of the g function, which is 3. Thankfully, u prime is easy, 2x plus 5. Rules we already know. So now let's do crisscross multiply. So I'm going to have 3x plus 1 cubed times 2x plus 5 minus x squared plus 5x times 9 times 3x plus 1 squared, all over the denominator of 3x plus 1 cubed squared. Okay, then you need to see the two big terms. Two big terms. And what do they have in common? A 3x plus 1 squared. So we're going to factor out 3x plus 1 squared. So that's going to leave us with a 3x plus 1 times a 2x plus 5 minus a 9 times an x squared plus 5x all over 3x plus 1. Then you need to think about the way your exponent rules work. And this is when they multiply, so it's going to be to the 6th power. Now that you have a matching factor in the top and the bottom, two of these 3x plus 1s are going to cancel with two of the ones in the bottom. And then we're going to FOIL this first pair and get 6x squared plus 15x plus 2x plus 5 minus 9x squared minus 45x all over 3x plus 1 to the 4th. We're almost there. So 6x squared minus 9x squared minus 3x squared. 15x minus 45x would be negative 30x, but then it's plus 2, so negative 28x plus 5 over 3x plus 1 to the 4th power. So that's the answer for D. And then I'm going to go ahead back up and do E. So I'm going to erase a little so I have some workspace. Okay, so for E, I see I have a product. So my U function is going to be 4 minus x to the 2/3. And my V function is going to be x plus 1 to the 1/2. Then U prime, that one's easy. Negative 2/3 x to the negative 1/3. But the V function, we're going to need a chain rule for that one. So let's come do it in a different place so it doesn't mess up our crisscross multiply pattern. So I'm going to find V prime over in a separate space where the inner function is the x plus 1. The outer function is the to the 1/2 power. So the derivative of f is 1/2 x to the negative 1/2. So then the chain rule says I need to put the g function into the f prime function. So this is going to be 1/2 x plus 1 to the negative 1/2 times the derivative of the g function, which happens to be 1. Okay, then let's do our crisscross multiply. So I'm going to have negative 2/3 x to the negative 1/3 x plus 1 to the 1/2 plus 1/2 times x plus 1 to the negative 1/2 times 4 minus x to the 2/3. and that is our y prime, which needs some simplifying. So it may really help to write it with no negative exponents before you decide how to simplify it. So I'm going to do that. So I need a common denominator. And my lowest common denominator here is going to be the two denominators multiplied together. So I'm going to have 2 and x to the 1/3 and x plus 1 to the 1/2. So my first fraction needs a 2 and an x plus 1 to the 1/2 in the numerator and denominator. And my second fraction needs an x to the 1/3 in the numerator and denominator. And let's see where that gets us. So I'm going to have this 2 times this -2, so -4. Then x plus 1 to the 1/2 times x plus 1 to the 1/2 is x plus 1. Plus, I'm going to go ahead and distribute and get 4x to the 1/3 minus x, add the exponents, over 2 times x plus 1 to the 1/2, x to the 1/3. We're almost there. Next to the last step, -4x minus 4 plus 4x to the 1/3 minus x over my denominator. And now we're on our last step. We have -4x minus another x, -5x, plus 4x to the 1/3 minus 4 over 2 times x plus 1 to the 1/2, x to the 1/3. So that is our final answer. Okay, so let's look at some applications, and really these applications are things you've done before. It's just the function now will require a chain rule, so that's really the only thing that's new. So let's look at this first example. And it says find and interpret f of 15. So we're getting pretty good at this. This just means put 15 in where you see the x. So you're going to have 0.8 times 15 minus 8, and then square that. And I'm getting 16 for that. And then let's make a little x and year chart, because I find this really helpful. It says x equals 11 corresponds to the year 2011. So they're asking me about year 15. So that's going to be in 2015. So my interpret would be in 2015, 16% of U.S. high school students were using e-cigs. And this is actual data again. So in 2015, about 16% of U.S. high school students were using e-cigs, and you can say according to this model, if you like, to be really precise. Okay, so then the B part says find f prime of 15. So we're going to first have to find f prime of x. Well, let's see, our inside function is the 0.8x minus 8. And my outside function is the squaring. So my derivative of f is 2x, and then I need to put the g function into the f prime. So f prime is 2 times the 0.8x minus 8 times the derivative of the g function, 0.8. So we can write that a little nicer as 1.6 times 0.8x minus 8. So that's f prime of x, but we were asked to find f prime of 15. So use your good function notation. Say, I'm finding f prime of 15. Then plug 15 into the formula. And I'm getting 6.4. So here's the interpretation. In 2015, the percentage of U.S. high school students using e-cigs was increasing at a rate of 6.4% per year. So remember that the units of derivative are units of y, percent, per units of x, years. So please study that sentence and make sure that you can reproduce it in the context of any given problem. Okay, and then one more example. This one I find interesting because it's an interest rate problem. So it says find dA/dr. So this is the same thing as a prime. It's just that other notation, the Leibniz notation. So let's see how we're going to find the derivative of this function a. So I see an inner function. It's going to be 1 plus r over 400. And it's always easier to do derivatives if you write any kind of multipliers out in the front of the variable. So this actually is g of r. So let me be correct here. The letters need to match. So that's g of r. So then we're going to have f of, it can be any letter, but f of r is going to be 8,000 x to the power of 20. So the derivative is going to be 16 with 4 zeros, so 160,000 x to the 19. And then we're going to take the g function and plug it into the f function to come up with a prime equals 160,000, 1 plus 1 over 400r to the power of 19 times the derivative of g, which is 1 over 400. So we should simplify that. Combine these guys to 400 times 1 plus 1 over 400r to the 19. Okay, so that's the A part. Then B says, find A prime when r is 2. So let's put 2 in for r. And I'm getting about 439.76. And this is going to be, let's see, amount invested, which is the value of the certificate. So A is in dollars. So this is dollars per the interest rate is the variable. So dollars per, how is the variable being measured in percent? So this is dollars per percent. So let's see if we can write our sentence. When the interest rate is 2% per year, the value of the CD is increasing, and you can either say at a rate of, or you can say by. Either of those works. Is increasing by 439.76 per percent interest rate. So when at the moment when the interest rate is 2%, the value of the CD is increasing by $439.76 per percent increase in interest rate. So another way of saying this would be thinking of it more as marginal. You could say when the interest rate increases from 2% to 3%, the value of the CD increases by approximately 439.76. So either of those is appropriate. The second one sounds a little bit more polished to me. The first one sounds a little awkward. So please make sure and ask questions if you have any.